Hi everyone, let's explain the technique called integration by parts. As you remember, we found this formula, the integral of u times differential of v equals u times v minus the integral of v times differential of u, because this comes from the derivative of a product of functions. So the derivative of f times g of x equals f of x times g prime of x plus g of x times f prime of x. We're going to use this formula, the derivative of a product, to verify our results. First of all, look at the integral. We have x times the square root of 4x plus 5. This is a product, and we cannot use the change of variable because x is not the derivative of 4x plus 5. That means that we need to use the integration by parts formula. So we need to make a choice for u and a choice for differential of v. What's the best? Well, in this case, u equals x, because when you obtain its differential, you're going to obtain 1 times the x, and that means lower degree, which is good for the second integral that we're going to find in the formula. So dv equals the square root of 4x plus 5 times differential of x. Then, in order to find b, which is what we need for the formula, we need to find the integral of differential of b. So I'm going to do the whole procedure for this one. So that will be the integral of the square root of 4x plus 5 times the x. In this case, well, we need to do the change of variable. We want to make u equals 4x plus 5, and then its differential will be 4 times the x. Since we don't have 4, we have to divide by 4, and then we're going to do the substitution, and we obtain the integral of u to the 1/2 times 1/4 times du. This fourth is a constant, and then the integral of u to the 1/2 will be u to the 3/2 over 3/2 plus the constant. If you simplify the fractions, you're going to obtain 2 over 12, which equals 1 over 6 times the square root of 4x plus 5 cubed. We're going to get rid of the constant because at the end we're going to add the real constant. So the function v equals 1/6 over times the square root of 4x plus 5 cubed. Now, we have to do the substitution, but I'm going to need some more room for this integral, so I'm going to stop here and I'm going to rewrite in the next slide. We have here all the elements. We have the formula, we have u, differential of b, du, and the function v that we obtained previously. And I have done the substitution, so look at this. U times b, it's x times 1/6 times the square root of 4x plus 5 cubed, minus the integral of b times differential of x. Now we need to find the integral of this. So we need the substitution or changing variable. So I'm going to make u equals 4x plus 5, and then its differential will be 4 times the x. Since we don't have 4, we're going to divide by 4. And then we're going to do the substitution. So this equals x times 1/6 times the square root of 4x plus 5 cubed minus the integral of 1/6 times u to the 3/2 times 1/4 times du. We can multiply those constants. Well, I'm going to write this first because we don't have a change in this part of the integral. Cubed minus 1/6 times 1/4 equals 1/24 times the integral of u to the 3/2 times the u. So we're going to add 1 to the exponent, and that will be 5/2 over 5/2 plus the constant. And then we're going to do the substitution for that u, but we still have to rewrite this part of the integral. Minus. If we simplify the fractions, then we have 2 over 24 times 5. Since 2 over 24 equals 1 over 12, then 1 over 12 times 5 will be 1 over 60 times the square root of 4x plus 5 to the 5th power plus the constant. And that will be the final result for this integral. Now, exercise number 2. First, we're going to check if we can use basic rules or changing variable. As you can see, we have x squared times natural logarithm of x times dx. We don't have an integral, direct integral for natural logarithm of x, so it would be a good idea to make u equals natural logarithm of x, because we have a differential or a derivative for that one. So I'm going to make u equals natural logarithm of x. In that case, differential of b would be x squared times dx. Then, if you find the differential of u, that will be 1 over x times dx. And if we find the integral of x squared times dx, we need only basic rules, and that will be x cubed over 3. And remember that I'm not going to write the constant here, because we want to write just one constant at the end. Now, let's do the substitution in the formula. Do you remember it? Okay, I hope you do. So the substitution would be u times b, which is natural logarithm of x times x cubed over 3, minus the integral of b, which equals x cubed over 3, times differential of u, which is 1 over x times dx. For this integral, we're going to write x cubed over 3 times natural logarithm of x, in order to avoid the mistake of multiplying avoid the mistake of multiplying x cubed over 3 times x, because this is the argument of the natural logarithm. So we're going to write it like this. Now, we need to find the integral of this, but before that we can simplify easily, because x cubed over x equals x squared over 3 times dx, and that integral can be done just by using basic rules. So that will be 1/3, and then we're going to do x cubed over 3 plus the constant. Finally, we obtain x cubed over 3 times natural logarithm of x minus 1 over 9 times x cubed plus the constant. This is an easier exercise, as you can see, because we don't have that many things to do. You can go back to this video as many times as you want. We have explained these 2 examples in class, you have copied them, and you have heard them from me. Now, if you need support, you can use this video.